Good everyone, my name is Graphics. Today we want to analyze this truss or frame structure using section analysis to get the forces in each member. Now, first you have to do, you go through the same process by calculating for the reaction in this structure, right, in this diagram, and also checking if the system is in equilibrium. Now let's start. You first of all start by drawing your free body diagram. Like I said, the free body diagram is the diagram that shows all the external force acting on the system. Now this is what we'll have. Now, this is a hinge support. A hinge support has two reactions, right? So I'm going to place the reaction here because hinge. This is coming up, and this is coming up this way, right? So I'll have this and this. I'm assuming a positive direction, right? So this will be, this is at point A, this will be my R A Y, and this will be my R A X, right? Now this is a roller support. Roller support is somewhere around here, right? I'll be having just one reaction pointing in the direction at which there is no movement, right? So this is point G, so this will be point E, so that will be my R E X, right? So this is A here, this is B, this is point C, will be somewhere around here, right? And this is D, point D, this is E, point E, this is F, point F, and this is what? G. So G does have one force acting downward, and that force is 5 kilonewton, right? So if you know very well that this is a free body diagram that we have here, we only are concerned with the external force, right? So we'll proceed. Now we know very well that we will start calculating for each of the reaction using the condition necessary for what? Equilibrium, right? So the first condition for equilibrium is the summation of f of x equals to what? 0. Don't forget that the angle here is what? 60 degrees. The angle here is what? 60 degrees. So now we'll proceed. Now the first condition is summation of f of x. Summation of what? F of x, which is the summation of all horizontal components equals to 0. And we are going to consider forward force to be positive and backward force to be what? Negative, right? Now let's see, we only have just one forward force here, and that is RAX. So I'll say that my RAX is equals to what? Is equals to 0, right? So that's the only force we have. We'll move forward to the next one. That will be summation of what? F of y equals to 0. That means all vertical components will be equated to 0. Now we are going to put our condition. We'll consider upward force to be positive and downward force to be what? Negative, right? Now how many upward force do we have here? RAY is upward, RAX is upward, right? So I'll say that my RAY plus REX. Now we have 5, the plate is facing downward, minus 5, 1 facing downward, minus 1, 2 facing downward, minus 2, then 1 also facing downward, minus 1. Everything equals to what? 0, right? So from here we'll be having this, my RAY plus REX minus 5 minus 1 minus 2, that is minus 8, I'll give you minus 9, equals to what? 0, So my RAY plus REX is equal to what? 9 kilonewton. So since I have two unknown, I'll call it equation what? Equation 1. Right? Now, the next thing we'll do is to calculate for the summation of moment about a point. Summation of moment about a point, but the point I'm going to be choosing with point A, because one of the reasons is I have two unknown there. I can take moment about any point, but this is the best point I can take moment. At point A equals to what? 0. So I'm going to consider, I'll consider the clockwise moment to be positive and anti-clockwise moment to be what? Negative, right? So let's see. If you look at this figure very well, very well, let's even come down here. I have a force that is coming downward here at this point here. Let me just show you what I'm trying to talk about. I have a force coming down here this way. Can you see that? So if from here to here is 3, that means half of here will be 1.5 and here also will be what? 1.5. And this force, since I'm taking moment about A, this force will be going this direction. And that is what? It's going clockwise, like I thought earlier. Because if you have a clock this way, this is 12, this is 6, this is 3, and this is what? 9. Anything going in direction is said to be what? Clockwise. And this guy is going in direction. So it will be 1 times distance from here to the way where I took moment. So 1 times 1.5. So I'm having 1 times 1.5. 1 times 1.5. Plus another one again. If you come here also, if you come here too, you discover that this is another force. The same thing happens here too. This is another force, because moment is force and distance, so you only consider focused on the what? The forces at the distance. Now this is another one again. If from here to here, C to E is what? 3, then half of it will be what? 1.5 and what? 1.5. But I'm taking moment from here to the point at which the effect is felt. So it will be 1.5 plus 1.5, that is 3, plus 1.5, that is what? 4.5, multiplied by what? The distance. It's still going in this direction, so it's still clockwise. So 2 times 4.5. 2 times 4.5. So I have 2 multiplied by what? 4.5. Right? Plus, now, same thing happened to the next one also. I have this. Right? Now if you look at it very well now, this force here, it is a reaction from here. What do you notice? It's a reaction. REX, this point here. And from here to here is what? Is 6. 3 plus 3 is 6. And it is going this direction. Coming, that's anti-clockwise, right? I mean, it's going this direction. Anything that's coming this way is anti-clockwise. So it will be minus REX times 6. Are we together? So this is what we have. Also, if you come back here also, we have another force here, which is 5. And look at the 5 is facing downward, and we took moment about point A. So the force, before that, we have 1 here. Let's do that of the 1. So let's see the 1. The force will be acting straight downward here. Right? So the distance from here is 1.5. Since everything here is an equilateral triangle, so equal distances, 1.5, 1.5. Right? So the distance from this force here to this direction is 6 plus 1.5, and that is what? 7.5, because from here to here is 1.5, to here 3 points, 4.5, 6 points, then 6 points, 7.5. Right? So we have 7.5 times, this is clockwise, going this direction here clockwise. So we have 7.5 times 1. So we move forward. 7.5 times 1 plus 7.5 times 1. Right? Now, the other force that we have here is this. This is 5. We discover that the 5 from here, this is 5. From here to here is 9. The entire distance is 9. And the 5 is coming this direction. Right? And that is what? Also clockwise. So 5 times 9. I'll be having my 5 times 9 plus 5 times 9 equals to what? 0. So at the moment we have. So let's start. We have 1 times 1.5 will give you 1.5 plus 2 times 1.5 will give you 9 minus 6 ROEX plus 7.5 equals 7.5 plus 45. 5 times 9 is 45 equals to what? 0. Now 7.5 plus 1.5 is 9, right? So we're having 63. Everything here we're having 63 minus 6 ROEX equals to what? 0. So 63 will now give me 6 ROEX when I take it to the side. Now we move forward, and that will now give me 63 all over 6 is equals to what? ROEX. So my ROEX here, ROEX will now be equals to 66 divided by 3, and that will be divided by 6, that will be 10.5, right? So we're having 10.5. Are we good? Now what you do here is you take your 10.5 ROX and substitute it into equation 1, right? So let's see that. So substitute it here. So substitute, let me just do it here. Now you substitute 10.5 in what? Equation 1. That's my REX, right? So from here, my equation 1 is telling me ROAY plus ROEX is equals to what? 9. So ROAY plus RS is what? 10.5 kilonewton. So we have 10.5 equals to 9. ROAY is equals to what? 9 minus 10.5. So my ROAY will now be giving me that will be having minus 1.5 kilonewton. That will be my ROAY, right? So we've gotten ROEX and what? ROAY and ROAX, right? So it's telling me my ROAY is minus 1.5, so I have to change the direction of the ROAY. Now we have ROAY. Since now ROAY here is negative 1.5, right? And our question here, it is facing up, which is what? Positive. We will change direction to be facing downward. So it will come here like this. So my ROAY will be equal to what? 10.5, right? So the next we have here is my 5 kilonewtons still remaining there. 5 kilonewton. Then also my ROEX still is positive. So ROEX is equals to what? That will be ROEX is 10.5. 10.5. This is not 10.5, this is 1.5 here. 1.5 please. Sorry for that. ROAY is what? 1.5. Now, this is what we successfully drawn. We know the angle in between these guys here are 60 degree, telling us is what? Is an equilateral triangle. So all the angle is 60 degree all through. Right? 60 degree, 60 degree, 60 degree, this, 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 and this. It's 60 degree. Now if you look at it very well now, we say we want to use the method of joint section analysis, right? So we are only allowed to cut through member. Section means you are cutting. We want to cut across the frame that we need. So we want to calculate each of this member, right? So the member I want, probably we know from here that if this is A and this is B and this is point C, this is point D, this is point E, this is point F, and this is what, point G. So the first at this point here, here we'll be having FAB. The first here will give me FBA. Here will give me this BC, FBC. Here will give me FCB. This will give me this is FC and D, so it will be FCD. Here will be FDC, right? Here also, this point here will be this ACIB, so here will be FAC. Here also will give me FCA. Here will be FCE, and here will be FEC. Here also, this is D and E, this is FDE. Here will be FED. Here also will be this EG, FEG, and here will be FGE. Here will be FFG. Here will be FGF. Here will be FEF, and the last but not the least, FFE, right? So this is what we have. Try the forces that is in each member here. Don't know that. Know that FAC is FCA, FEC, so they are all equal, right? So we want to section. For instance, we want to know the member in this. Probably I want to know what FBD is and FDB, also FDF and FFD. So let's see. So I'm allowed to just cut through the section that I need. So if I want here, you must cut at most 3 parts, 3 member. So if I'm cutting here this way, I'm going to be having this, right? So I'm cutting here, this, right? So I have section here. So if I section here, this is what I am going to be having. So this is what we'll be having. I have this 1 kilonewton facing downward. This is here, 1 kilonewton, and this is my FBD here, because I've cut it. So this will be my FBD. Now also I still have what I'm still remaining, which is my FBC. So I have this here. This will be my FCB. Here also. This will be my FCD. So, and here will be my FCE. This is what we just did here. This part you see here, FCD, is this part that will cut off here, FCD. FCE, where we cut off, so we're having FCE here, right? So this is what we're having here. So the other part also, if I want to use that part also, I'll have this. This is point A, which I have my force coming down here. And I say this is what, RAY. And that is what, 1.5 kilonewton. And this is my B, point B. And this is my point C here. So if you do for the other aspect, you'll be having this. If you section here too, taking at least 3 member from here, you'll be having this. right? So you cut it off, isolating the FCD. Now look at this. Now you have in this when you section it, this side that you have cut off from here, this is FED, this is FEC, this FEC, this is FEC, and so on. So section them, right? So we'll now start considering them one after the other. So let's see how we go about that. One of the advantage of section method is just that we use it to get targeted members, like a particular member. In joint, you cannot target a particular member. You need to start from the beginning and start moving. But in section, you are given a target. Probably you want to know what FBD is, what FCB is, so you are going to cut through those sections, right? Which is what we just did. So in this frame structure now, we have to get what BD is, CD is, CE is, DE is, and DF is, right? That's why we had to cut through this member to be able to analyze them. So now we want to consider triangle A, or we want to consider joint triangle ABC. This is this triangle we want to consider here now. So let's see. Now using the condition for equilibrium, we know very well that my summation of what f of x, right, is equals to what? 0. Now we want to consider the forward force to be positive and the backward force to be what? Negative, right? So let's see. The forward force here we have is FCE. FCE is forward, so it's positive. Also FBD is also forward, plus what? FBD, right? Now if you look at this FCD, it is inclined, so you'll be having this. It is inclined. This will be FCD cos 60. That is what will be here, right? And this one also coming up, we have this, and this will be FCD sine 60, right? So you know, as you are dealing with horizontal component, so facing forward this will now be plus FCD cos 60 equals to what? 0. I'll call it equation 1. Now similarly, I'll say the summation of my f of y equals to what? 0. And I'm going to consider upward force to be positive and downward force to be what? Negative, right? Now I have this facing down, that is arrow AY, which is 1.5 minus 1.5. Are we good? And I'm having this minus 1, this one up here, and this inclined force that I've resoluted, which will be the one facing up, it will be plus FCD sine what? Sine 60 equals to what? Equals to 0. Now in doing that, I'll be having minus 2.5 plus FCD sine 60 equals to 0. So the FCD will now be equals to I can write FCD cos sine 60 will now be equals to what? 2.5. If I take this to the side, so the FCD will now be giving us 2.5 all over what? Sine 60. So when you press that, you'll be having 2.5, that will be 2.887. So my FCD will be equals to what? 2.887 kilonewton. Right? So now the next thing is you take moment about a point. Taking moment about a point. But the point I want to take moment should be at this point where I have multiple unknown. Right? So I have a lot of unknown here, so it's better for me to take moment about this point so that I can isolate other parts too. Now if I do that, I'm taking moment at this point, C equals to what? 0, and I want to consider my clockwise moment to be what? Positive, and my anti-clockwise moment to be what? Negative, right? So if you look at it very well, let's take some analysis here. If you look at this triangle here, this triangle that we have here, right? The force is acting straight down here, so this is forming a triangle, right? If I break this force down this way, right, the force is going towards this direction, right, and that is anti-clockwise. But I know this force here is what is, I know this distance here, I don't know this distance, I don't know this distance here. So since it's coming anti-clockwise, distance from here to here is what I don't know because it is inclined. So what I'm going to do now, I'm going to draw this triangle again. I'll draw it out again. I'll make it a sidewalk. I'm drawing this triangle out, and I'm having this. Can you see that? So we know the angle here is what? It's 60 degrees. This is B, this is C, and this is what? Let me call it point P, since I don't really know what. Let me call it point P. I don't know what that side is. And this is, I want to get to know what the distance is and what the distance is. So we know that if AC, or we know that AC is what? Is 3, right? So what I will do here is just this. If I use my sine 60, sine 60 is opposite BP over what? Hypotenuse BC, right? So my BP will now be equal to what? BC sine 60, but BC is equal to what? AC, right? Is equal to what? AB, and that is equal to what? 3, because the total distance is an equilateral triangle, so all the sides are equal. So I can now say that my BP is equal to what? 3 sine what? Sine 60. So BP is equal to what? 2.598 meter. So the distance from here to here is what? 2.598. That is my BP. So I can similarly say distance from here to here is what? 2.598. Right? So if you continue, you do for that, of course. Also, my cos 60 is equals to what? Adjacent from the word car. Adjacent, this is the adjacent PC, all over what? Hypotenuse, that is what? BC. So my PC will now be equal to what? BC cos 60. So my PC will now be equal to, we know BC is 3, right? From what we analyze here. BC is equal to, is equal to AB is equal to 3. We'll be having what? 3 cos 60. So my PC will give me what? 1.5, right? Which we already know right from time here. That is what? 1.5, right? So from here to here is 1.5 meter. So that means the distance from here to here is what? 1.5 meter, right? So we'll now put them here. Now let's start. So it's easier for you to analyze it this way. So from here, we took moment about point C, right? Moment about point C. So we start from the beginning. This force is perpendicular to this distance here, because I took moment here. So it's coming towards this direction, and that's anti-clockwise. So because anti-clockwise, we say anti-clockwise is negative, so minus 1.5 times 3. So move forward, and we're having minus 1.5 multiplied by what? 3, plus, come here again, The next force is this force that is acting downward here. From here to this point is what? Minus 1 times 1.5. We have minus 1 times what? 1.5. Plus the next one is this, because we're having two forces here. So this one is perpendicular to this vertical distance that I cut here, right? So it will be FBD times what? 2.598. So but how is it going? It's coming this direction. And that is what? Clockwise. So FBD times 2.598. No, calculated it. So FBD multiplied by what? 2.598. 2.598, we know it is what? It is 3 sine 60, right? So what else again? That is what we have. So equals to what? 0. Now 3 times 1.5 will be minus 4.5, right? So the next thing will be minus 1.5 plus 2.598 FBD equals to 0. So this will give me minus 6, right? So we're having minus 6 plus 2.598 FBD equals to 0. So 2.598 FBD is equals to 6. FBD will now give us what? 6 divided by what? 2.598, right? So my FBD will now be we have it to be 2.309 kilonewton. That's my FBD. Now we'll put FBD in equation 1. So substitute FBD equals to 2.309, right? And FCD equals to what? 2.887 in equation 1 above. Now this is my equation 1 above here, and that is FBD plus FCE plus FBD cos 60, right? So we have FBD plus FCE plus FCD cos 60 equals to 0. Now from here, let's input FBD is 2.309, right? Plus FCE giving us what? 2.887. That's FCD. We have FCD here, sorry, plus FCE, not 2. We have plus FCE. We don't know our value for FCE, right? Now plus FCD, that is 2.887 cos 60 equals to 0. Now my 2.309 plus FCE plus 2.887 cos 60 will be 1.4435 equals to what? 0. Now if you add plus 2.309, that will give me 3.753. We have 3.753 plus FCE equals to what? 0. So my FCE is equals to what? Negative 3.753 kilonewton. All good? So We are going to repeat the same process on this aspect too. We just analyze this. So the same thing is applied here. Is that taken? So the same thing is applied here. We know that both of them are similar triangle, right? And they also see the grid. So we know from here to here is still the same thing as from here to here, right? So we are going to resolve this also. We're going to consider triangle what? EGF. Consider triangle EGF. Consider triangle EGF, right? So the first thing we look for summation of what? F of what? X equals to 0. And we'll also consider the forward force to be positive and backward force to be what? Negative. So the forward force positive, backward negative. Now we have backward force here minus FCE, right? Minus FCE. Now this one also backward minus FFD, right? And what else do you have? This inclined force will resolve it into vertical and horizontal component. The horizontal component facing backward is what? FED cos 60. So minus FED cos 60. These are the horizontal components we have there. Equals to what? 0. So I will term it what? Equation what? Equation 1. Now the next thing I'm going to do is summation of what? F of y equals to 0. And I'm going to consider, I'll consider upward force to be positive and downward force to be what? Negative. So my upward force here is FED sin 60, that inclined force. FED sin 60, right? Plus now let's see, look at this is facing downward, so minus 1 minus 5 and minus 10. They're all 10.5. They're all what? Facing downward. Is that taken? So equals to what? Equals to 0. So from here we left with FED sin 60. So minus 6.5. So this will be minus 1 minus 5 minus 6 minus 16.5 equals to 0. So FED sin 60 will now give us 16.5 when it's coming to become positive. So FED will now be equals to 16.5 all over what? Sin 60. So the FED we have will now be 16.5 over sin 60, and that will be. Now if you look from our main diagram here, the arrow x is what? Is facing up, so we need to correct it, which is what? 10.5. sorry, so we'll come back here and correct this guy. It is not facing here, it is facing what? Upward. So ignore this, it is facing upward. So it's facing upward, that means to make it be what? Positive. To be what? Positive. So I'll be having plus 10.5. So 6 minus that will give us minus 4.5. Minus what? 4.5. So we're having 4.5 here. So 4.5 divided by sin 60 will be 4.5 divided by sin 60. That will be 5.196. 5.196 kilonewton. When doing this, you have to be very careful to avoid silly mistakes. Now, the next thing we'll now look for will be summation of what? Moment about point where? About point E, right? So taking moment about point E. So we're going to be having this equals to 0. So from here, now we have this taking moment about E. Everything here is what? 0. Now this 5 will be coming towards this point, and that is what? Clockwise, because when you have your clock this way, this is 12, this is 6, this is 3, this is 9. When it's going here, that's clockwise. So I have 5 times distance from here to here, and that is 3. So I'll be having 5 times 3. 5 times 3 plus the next one is this guy from here, acting at the center of this being here. If you remember, acting at the center of this being here, and it's going this direction, and that's also clockwise too. So 1 times 1.5, half of this is 1.5, so 1 times 1.5, 1 times 1.5 plus, now the next thing we'll do is this force here is going towards the direction here, and that is what anti-clockwise. But we know distance from here to here is the same thing as from here to here, which you calculated to be what? 2.598, right? So it will be minus FFD times 2.598. So we have minus FFD times 2.598. Now from here, this is all what we have, right? So we'll continue. Equals to what? Equals to 0. So from that aspect, 5 times 3 is 15 plus 1.5 minus 2.598 FFD equals to 0. So 16.5, we have 16.5 minus 2.598 FFD equals to 0. So 16.5 is equals to 2.598 FFD, right? Because when it's coming, it becomes positive. So you divide both sides, we'll now have FFD is equals to what? 16.5 all over what? 2.598. So 16.5 divided by 2.598 will have 16.5 divided by 2.598, and that will give us 6.35. So my FFD will be equal to what? 6.351 kilonewton, right? So I can input this into equation 1 to get my F. Oh, I don't really need that. I've already gotten it in the other equation. So this is what we're having: FED, FFD, right? And I already have my FCE from what we did previously, right? So that is all we have to do, and we are done. You just have to draw your table and table all what you have calculated. We have member BD, member CD, member CE, and member what? DF. So this is member DF or FG is giving us 6.351. 6.351, that is what? FG. This one, right? What is happening is positive here. It's positive here that I calculated for it. It's positive, but here it is what? Negative. So we have to change direction. So the right one will be is going inward, right? So since inward force is called what? It's called what? This is tie. And when I call it struct going inward, because by the time we work our true diagram, it is going outward. So when I calculated, I realized that it was positive, so it's going inward. Now SCE, the next one will be my CE. My CE I calculated for is negative here. Calculated for CE here to be what? Negative 3.75. So if you come and look at my CE at this point here, my CE is negative, but it's falling right. So I'll change direction to go backward because it's negative, so I'll make the arrow face the negative side, and that will be struct also. So my CE is also what? Is struct. and it's given as 3.753. Then CD, the CD calculated for is 2.887, and CD here is positive, so it's also a tie. So CD is 2.887, and is what? A tie. Then the BD calculated for here is calculated for BD to be BD 2.309, so it's positive 2.309. Now BD is going positive. If you look at diagram here, so that is what? A tie, outward force. So I'm going to write a tie here. So this is what we have. So if you find this video helpful, don't forget to click on subscribe button. Thanks for watching.